Well, as promised in the previous section, now we're going to do applications, arc length and sector. So this is all about circles to begin with. So if you have a circle and the radius is r, then two important formulas are the area equals pi r squared. So that would be how much space is inside of the circle. And then the circumference is 2 pi times the radius. And circumference means that if you start here and you walk along the outside of the circle, then how far would you walk if you went around once? Now, what if you have a circle? Suppose that right there is a pizza, and then you cut a slice. Why cut it into skimpy little slices when you could get a big chunk like that? So arc length would be the outside crust right here. So in other words, it's just a fraction of the circumference. So that is arc length, because it's an arc and you're finding its length. Then, if you wanted to know how much space this pizza takes up, that area, well, first of all, the shape is called a sector. So the shape of a piece of pizza is actually called a sector. And then we'll find the area of it. And again, it would just be a fraction of the area formula. So for example number 1, here's a circle. The radius is 8 inches. And then suppose that this angle right here and this angle right here is called the central angle, like the center angle. The central angle, the central angle theta is 60 degrees. Part A, find the arc length. So in other words, what's this length right here? And arc length is sort of long to spell out each and every time. So instead, we use the letter S for arc length. Okay, so one way to do this is, if this is 60 degrees, that's just a fraction of the whole circle. It would be 60 degrees out of a total 360 degrees. And when you reduce this, it becomes 1/6. So it's 1/6 of the circle. And if you know that it's 1/6, then just use these formulas over here and we'll just multiply by 1/6. So for arc length, that comes from the circumference formula. So that means that the arc length is going to be 1/6 times 2 pi times the radius. So let's see, that would be, I guess I could just use the decimals instead of the exact answer. So that would actually be 16 pi divided by 6. So as a decimal, it's going to be 8.378. And because it's a length, this is going to be in inches. Okay, now watch this magic. So I'm still working on number 1, part A. And the theta equals 60 degrees. So I'm going to redo this problem. But instead of using degrees, I'm going to change this to radians. So 60 degrees, then change that to radians. So that would be pi over 180. So when you reduce a 60, we'll divide into 180 3 times. So that's going to be pi over 3. Okay, so that's the theta in radians. Now, S is equal to, so the radius is 8. The angle is pi over 3. And how much is that? 8 times pi over 3. Ta-da! It's the same thing. The exact same answer. Okay, so an important fact for arc length. That S is equal to r times theta. So just take the radius times the angle and you're done. As long as the theta is in radians. That's why I was emphasizing it over here. Okay, now on to part B. Find area of that sector. So we're still talking about the circle has a radius of 8 inches, and this is still 60 degrees. And then find out how much this red area is right here. So since this is in degrees, I could still do 60 degrees over 180. Whoops, I meant to say 60 degrees over 360 total. Sorry about that. So start it off the same way as last time. And when you reduce, this is 1/6 of a circle. And since it's talking about area, we could use that. The area is, the formula for area is pi radius squared. And then this is just 1/6 of a circle, so multiply by 1/6. And then we just use A for area. So pi, that would be 64, and divided by 6. So it would be 33.51, and then this is area, so it would be in square inches. So we have arc length, area of a sector. Sometimes this is called A with an S to say area of the sector. Next up, something else that goes in a circle. So for example number 2, so in Las Vegas, there's the world's largest Ferris wheel. It's called the High Roller. It's 520 feet tall. So that means if you look at the circle that it makes, then from top to bottom, that's 520 feet. In other words, the diameter is 520 feet. So my formulas use radius. So I need to know what's the radius. What's half of that? Well, half of 520, so half of 500 would be 250. Half of 20 is 10, so it's 260 feet for the radius. All right, then for question A. How far do people travel if it rotates through 25 degrees? So they get on right here or wherever. Let's just say they're going to start right there. And then it starts rotating this way until this is an angle of 25 degrees. Then how far do they travel? So it's either asking for arc length or it's asking for area. Well, since the people are traveling along the outside of it, that's asking for arc length. And I prefer to use this little easy formula that arc length is equal to r times theta as long as the theta is in radians. So first of all, change 25 degrees to radians. So that means it's going to be pi over 180. (25) divided by 180, then math, reduce the fraction, it's 5 pi over 36. So that is the theta, and now it's in radians. So now I can just use this formula. The radius is 260. So S is equal to R times theta. So 260, and then 5 pi divided by 36. So they would travel 113.446 feet, because this is in feet. Then for question B. So of course I Googled this up. It takes 30 minutes for one rotation. Because the idea is not that it's a thrill ride and you're supposed to go fast and get scared. The idea is that you're going up over Las Vegas and then you get to see the city and go, oh wow, look at that. Oh, look at that dude down there. You see that guy? So my question is, how fast are passengers traveling? Okay, so 30 minutes, they're going to go one time around. So that means I need circumference, which equals 2 pi times the radius. So how much is 2 pi times 260? So they're going to travel 1,633.628 feet. Now, I'm just going to use the idea that distance equals rate times time. Or if you divide both sides, distance divided by time equals rate. So how fast means rate. So solve for R. So it's just the distance divided by the time. So it's the distance, let me switch back. So it's the distance divided by the time. So then the rate would be 1633.628 feet every 30 minutes. So I just need to take my answer and divide by 30. So they're traveling at 54.454 feet per minute. So this one is actually done, but personally, I don't really know 54 feet. Okay, I can imagine 54 feet and it would take a minute. That doesn't seem very fast. That seems like 2 miles an hour. I don't know. So what I'm going to do is just on some scratch paper, figure out, just for my own curiosity real fast, how do you convert? So 54.454 feet per minute. Then there's 5,280 feet for 1 mile. See, that right there is what I'm talking about with our system. Why is it 5,280 feet that makes a mile? If it was metric, it would make more sense. Anyway, I'm done with my rant. So now the feet and the feet will cancel. So this would be miles per minute. And then there's 60 minutes in 1 hour. And then minutes and minutes will cancel. So if I take the 54.454 and I multiply by 60 and I divide by 5280, whoa, they're not even going 1 mile an hour. They're going 0.619 miles an hour. Just slowly moving through the desert air. Okay, then on to another type of example. As soon as I get another piece of paper. Example number 3. So suppose that you have a pulley. So it's fixed, it's bolted into something. Maybe it's a 2nd-story building. And then you've got rope that goes up around the pulley and then back down. And then maybe this is like a bucket of water or something like that. You're trying to pull that bucket of water up to the 2nd story. So the pulley has a 0.6 foot radius. So when you work on these problems, always make sure if you're not given radius, if you're given diameter, you would have to cut it in half. But in here, that is radius. So then how far does the bucket move if the pulley I was doubting how to spell pulley, but I'm pretty sure it's with EY. If the pulley rotates through 6 revolutions. So this is actually talking about arc length. Because as the rope goes through the pulley up here, it's going through an arc. And then this rope right here would eventually go up and around the top of the pulley, so it would have to go through an arc. So basically I need to know how much rope is going to be pulled up, because that's how much the bucket is going to be pulled up. How much rope is going to be pulled up if this goes around 6 times, 6 revolutions. Okay, since it's talking about arc length, I could use the idea that circumference is equal to 2 pi times the radius. And this means that it goes around 1 time. So as it goes around 1 time, this red part goes up here, it goes around, it drops off. The next part of the red part goes up there, it drops off, etc. So when it goes around once, that's going to be how far the bucket travels. Now do that 6 times. So multiply both sides by 6. And then that's it. So how much is 6 times 2 pi times 0.6? And that would be 22.619, and the units are in feet, So it would be pulled up a little more than 22.5 feet. Every 10 feet is a story, so actually that would take it up 2 stories. So that would actually take it to the basically the beginning of the 3rd story. Somebody on the 3rd story could grab that bucket and they could have some free water. Now for the last example. So instead of having 1 of these, what if you have 2 of these? So you have these 2 gears. And so there is a big gear, and then it's got like little teeth in it. And then there's a smaller gear, and it's got little teeth in it. And then their teeth go like this, and then that's how it has friction, and one of them can cause the other one to go around. Or the other way you could look at it is you could take these 2 wheels and you could separate them, and then they could be interlocked with a chain like on a bicycle. Same idea. Okay, these 2 are interlocked. So this small one, the radius is equal to 0.4 inches. So these are small gears. And this one, the radius is 1.2 inches. I'm going to call this one R1 because it's the bigger gear, and R2 the smaller gear. So how much does the small one rotate? How much does the small gear rotate? If the large gear, larger because it's not really large, if the larger gear rotates 65 degrees. Okay, so first of all, for the large gear. For the larger gear, we've got that the radius is equal to 1.2. And where they're touching, that's much like this rope over here. The rope is touching the pulley for a while, but while it's doing it, it's creating an arc length. Well, basically the same thing right here. Like if this was paint right here, then it could basically, as it rotates, it's going to force this one to rotate and it can paint it, and we need to see how much gets painted. Okay, back to this one. So theta is equal to 65 degrees, and I prefer to use the formula S equals R times theta if it is in radians. So I'm going to change this to radians. So that would be pi over 180. And now that's in radians. And then find out the arc length. So arc length is equal to R times theta. So that's 1.2 times 65 times pi over 180. So that's a 1.361, and this is in inches, right? Yeah, inches. All right. Now work on the small gear. Well, because these 2 are interlocked right here, if this one has an arc length of 1.361, then this one's going to have the same arc length because they're touching right there on the outside edge. So I know that for this one, the S has to equal 1.361, but this small one is going to have to be rotating faster to keep up with the big gear. So this one will be rotating like this, and then this one will be rotating faster. So in other words, the angle is going to have to be bigger. Okay. So we can still use the formula S is equal to R times theta, and plug in 1.361. The R is a 0.4, and then solve for theta. So to solve for theta, all we need to do is divide. So it's going to be 1.361 divided by a 0.4. So a 1.361 divided by a 0.4 is 3.403. And this is in radians, but because the problem is given in degrees, then I should respect their choice of degrees and I should change this to degrees. So then multiply by 180 over pi, and now it will be in degrees. So just take the last answer and multiply by 180 divided by pi. And because it's multiplication and division, you don't have to put parentheses. You can if you want. And so that would be approximately 195 degrees, or more precisely 194.949 degrees. So if the big one rotates 65 degrees, the small one's going to have to rotate approximately 195 degrees.